For more than 4 decades, Voyager 2 has wandered silently into the vast unknown, traveling far beyond the planets and past the cold frontier of our solar system. Launched in the late 1970s, it was expected to fade quietly, its faint signal eventually lost in the cosmic background. But against all odds, it continues to send back information, data that has not only defied expectations but also shaken our understanding of the universe. Recently, Voyager 2 transmitted readings so striking that they made scientists stop in their tracks. The spacecraft had crossed a line that wasn't supposed to exist in such a sharp form, the boundary of the solar system. Instead of a soft fade into interstellar space, Voyager 2 found a wall. That boundary, known as the heliopause, marks the point where the Sun's influence ends and the galaxy begins. For decades, researchers assumed the solar wind, charged particles streaming from the Sun, would gradually dissolve into the interstellar medium. But Voyager 2's instruments told a very different story. The transition was abrupt. Radiation spiked by more than 70%, plasma density leapt upward, and the structure of the magnetic field changed almost instantly. It wasn't a gentle crossing. It was as though a veil had been pierced, and suddenly the spacecraft was no longer inside a protective bubble but outside in a far more hostile realm. This revelation changed everything. The heliosphere, once thought of as a vague, theoretical concept, was suddenly revealed as a defined shield, a structure shaped and sustained by the Sun. Within this shield, cosmic rays are filtered, radiation levels are manageable, and conditions are relatively stable. Beyond it, the environment is chaotic, filled with high-energy particles and volatile magnetic fields. Voyager 2's discovery forced scientists to rethink the solar system, not as a solitary collection of planets drifting in emptiness, but as a fortress surrounded by an invisible barrier. Stepping outside of it meant exposure to the raw, unmediated forces of the galaxy. What made the discovery even more surprising was the realization that this barrier isn't fixed. It breathes with the rhythm of the Sun's activity. The heliosphere expands when the solar wind is strong and contracts when it weakens, meaning its protective shield is never the same from year to year. Voyager 1 and Voyager 2, though following different paths, confirmed this by crossing into interstellar space at different distances. The boundary isn't symmetrical, it stretches and recoils, distorts and shifts, shaped by solar cycles like the lungs of a living organism. The implication is unsettling: Earth's safety depends on a barrier that is both fragile and dynamic, one that could weaken or fail, exposing us to galactic radiation in ways we still don't fully understand. As if this wasn't enough, Voyager 2 has also encountered anomalies that leave scientists with more questions than answers. In 2019, the spacecraft briefly went silent. For a few tense hours, all instruments shut down, and no signals came from across the abyss. Then, without warning, it powered back on and resumed transmissions. Engineers attributed it to a minor software or hardware glitch, the kind of hiccup expected in a spacecraft so old. But the data revealed something stranger. Right before the blackout, Voyager 2 detected sharp electromagnetic fluctuations and spikes in particle energy. Some researchers suggested it may have passed through a highly energized plasma pocket, perhaps the shockwave of a distant supernova, or even an unknown layer of interstellar matter. The possibility lingered that this wasn't just a technical fault but a reaction to something in space we hadn't known existed. And the mysteries kept coming. Once outside the heliosphere, Voyager 2 began recording disturbances that looked eerily like weather, waves of high-energy particles, sudden shifts in magnetic fields, and rhythmic surges of galactic radiation. At first, scientists tried to connect these patterns to solar events, such as flares or coronal mass ejections, but the timelines didn't fit. Instead, the disturbances aligned with much more distant sources: supernova remnants, stellar winds from giant stars, or even the collective effects of galactic forces operating on scales far beyond our neighborhood. It was as though the spacecraft had sailed into an interstellar ocean filled with invisible currents, turbulence, and storms. Perhaps the most astonishing discovery of all was the alignment between the Sun's magnetic field and the galactic magnetic field outside the heliosphere. Instead of the expected turbulence at their meeting point, the fields seemed to align almost seamlessly. This unexpected harmony left scientists baffled, suggesting that the structure of the galaxy itself might be shaping the environment around our solar system in ways no one had anticipated. Voyager 2's journey has redefined the way we see the edge of our solar system. What was once thought to be an indistinct boundary has been revealed as a sharp threshold. Beyond it lies a realm that is not silent but alive with activity, filled with dangers we are only beginning to understand. The spacecraft, carrying humanity's message to the stars, now drifts through this uncharted territory. It is not just a probe of science but a lone witness to the hidden structure of the universe, sending whispers back across billions of kilometers, reminding us that the cosmos is far less empty, and far more complex than we ever imagined. For many years, Voyager 2 has served as a lone ambassador, journeying farther from the planets into a darkness we once considered simple and empty. Launched in the 1970s as both a mechanical explorer and a time capsule, it has far exceeded expectations, consistently sending back signals. Recent messages, however, are anything but subtle. These revelations have prompted scientists to rethink what the edge of our solar system looks like and what it signifies to have crossed that boundary. What Voyager 2 discovered was not a gradual transition into the galaxy, as textbooks suggested. The heliopause, the point where the Sun's influence ceases and interstellar space begins, did not gently fade away. Instead, it became sharply defined. Radiation levels surged, plasma density increased dramatically, and magnetic fields shifted abruptly, creating a sense of intention. There wasn't a slow dissolution. A clear line marked a threshold, reminiscent of a seam in space. Crossing it felt akin to stepping through a doorway into a realm governed by different physical laws. Within the protective bubble formed by the Sun, conditions remain stable. Cosmic rays are filtered out, charged particles are moderated, and the environment feels relatively familiar. Outside, everything changes drastically. Particles strike harder, magnetic flux becomes erratic, and the radiation intensifies. Voyager 2's findings transformed the heliosphere from a mere concept into a concrete barrier, one that shields us from the more violent aspects of the galaxy. The notion of our solar system being a solitary island in a vast ocean no longer holds true. Instead, we exist as a fortified outpost behind an unseen wall, with a turbulent frontier beyond. Even more concerning is the fact that this barrier is not fixed. It fluctuates in tandem with solar activity. Over its 11-year cycle, the heliosphere expands and contracts, stretching outward during rapid solar winds and receding when the Sun calms. Voyager 1 and 2 crossed at different times and locations, revealing that the edge is distorted by our star's rhythms. Consequently, Earth's protection isn't constant. Sometimes the shield tightens while at other times, it weakens, inviting more galactic radiation to approach us. The idea that our planet's security hinges on the Sun's behavior is both captivating and troubling. There have also been strange disruptions and anomalies. In 2019, Voyager 2 experienced an unexpected blackout, causing worry regarding the aging spacecraft. Engineers eventually attributed this silence to hardware or software issues, but the moments leading up to the blackout featured electromagnetic spikes and sudden increases in particle energy. Some scientists suggested harmless explanations, such as pockets of energized plasma, echoes from distant supernovae, or shock waves traveling through interstellar material. Others speculated that it might indicate entry into a zone with uncharted properties, something dynamic and reactive rather than random. Whether it was a glitch or a response, This incident suggested that the space beyond our heliosphere is more than a mere void. It can actively influence a vessel passing through. Voyager 2's instruments measured more than just isolated shocks. They uncovered patterns, oscillating waves of high-energy particles, fluctuations in magnetic fields, and rhythmic surges of galactic rays that resembled weather patterns. Initial investigations aimed to connect these phenomena to the Sun, looking for flare impacts and coronal mass ejections. However, when those projections didn't align, focus shifted outward. Patterns appeared to coincide with distant events, remnants of ancient supernovae, persistent stellar winds, or the cumulative effects of galactic forces. It felt as though Voyager had navigated into a hidden ocean of currents and storms, a turbulent medium shaped by events far beyond our immediate surroundings. One of the most baffling discoveries involves magnetic alignment. While theories predicted disorder and conflict, Voyager 2 encountered unexpected harmony. The Sun's magnetic field was nearly in sync with the galactic magnetic field beyond. Two unsettling explanations arise. Either the Sun's consistent outflow gradually shaped the surrounding space over eons, or the area beyond us was already structured to align with the Sun's magnetic field. If the latter holds, our solar system may exist within an expansive magnetic architecture, one possibly extending across vast regions of the galaxy. Such a realization alters our understanding of interstellar interactions, suggesting that space may possess greater organization than chaos. When these fields align, cosmic rays could have more efficient pathways into our system during times of solar calm. Then, there's the golden record attached to Voyager, a thoughtful, hopeful offering to any who might discover it. For years, it symbolized human optimism, a collection of images, sounds, and instructions designed to introduce Earth to the cosmos. Yet, considering the sharp, reactive boundary we encounter, that record takes on a new significance. If the heliopause is an edge that acknowledges passage, did we unwittingly announce our existence and location the moment Voyager crossed? Was the record simply a friendly gesture, or an inadvertent display of vulnerability? This inquiry dances between wonder and apprehension. Are we merely sending a message, or are we unlocking a door that someone, or something, might be listening behind? Was Voyager 2 solely an explorer, or has it inadvertently become a signal? Share your thoughts in the comments. Did the probe uncover something unexpected at the solar system's edge, or are we merely realizing that space is stranger, and more structured, than we've ever believed? If this discussion sparked your curiosity, subscribe and share it with fellow mystery enthusiasts.